Which of the following expression is not a polynomial? Polynomial is when the constant terms means the numbers 2, 3, 4, 5 or 5 by 6. They are joined with variables. Variables are x, y, x square, y square. When the constant and variables are joined by 4 operations per se, addition, subtraction, multiplication and division, these terms will be polynomials. And the condition for being a polynomial, the first one, the power of variable should be a non-negative integer. Now, non-negative integer means the power should be either plus 1, plus 2, plus 3. It cannot be a negative integer. Also minus 1, minus 2, it's not possible. Or it can be 0 also. So these are the only possible powers. Suppose if there is a power minus 1 with a variable, then it will not be a polynomial. Suppose there is a power 1 by 2 of a variable, then it will not be a polynomial. On this slide, let us analyze the option number 1. Here the variable 6y cube, variable is y, power is 3, which is a plus. Possible. Y square, again the power of y is 2, which is a non-negative integer. Here 2y, no power means power 1, again a non-negative integer, so this is a polynomial. Option B, look at the variable, it is x square y. Here the power of x is 2, which is a non-negative integer. Power of y is 1, a non-negative integer. Second term, x square y square, the power of x is 2, which is a non-negative integer. Power of y is 2, which is a non-negative integer. Third term, 6y cube, it's a trinomial. Power of y is 3, it's a non-negative integer, so this is also a polynomial. The third term, here the power of a is 3, which is a non-negative integer. Power of a is 1, which is again a non-negative integer. X powered 4 is a non-negative integer, so this is also a polynomial. Look at the option number 4. In the numerator, x powered 4. X powered 4 means the power of variable x is a non-negative integer. Completely fine, this is x square, y square. Power of x and y are 2 and 2 non-negative integers. Completely okay. But now, look at the denominator y. If I ignore the numerator, it will become 1 upon y. 1 upon y is y power minus 1. It's a negative exponent. So here I see the power of y is a negative integer. So option number D is not a polynomial. And that is our answer here. Answer will be option number D. 1 upon y is y power minus 1 is a negative exponent. And since the power is negative, this is not a polynomial. Which of the following expression is a polynomial? The condition of being a polynomial is the power of variable should not be a fraction. It should not be a negative integer. Now, keeping these two conditions in mind, let us analyze all the 4 options. First option is y square plus root 2y bracket x minus 4 plus x. Here the power of y is plus 2, so it is a positive integer. In the second term, don't get confused by root 2y. Y is not inside the square root, so the power of y is 1, which is a non-negative integer. Again, here x power is 1, this x also has a power 1. So this is actually a polynomial. Option A is a polynomial. Second option, this is cube root of 9 x, which can be expanded as cube root of 9 into cube root of x. power, so it cannot be a polynomial. Option C, a power minus 1 by 2. Now since the variable a has a negative as well as a fractional power, this will not be a polynomial. Option number D, 4 root x plus xy minus 1. Here the variable is root x. Root x means square root of x, which is x power 1 by 2. So the power of variable is in fraction. So this is also not a polynomial. Our answer is option number A. What is the degree of the polynomial 2a square plus 4b power 8? Degree of polynomial is the highest power of the variable for example here 2a square plus 4b power 8, this is a binomial. There are two terms. However, if there is only one term, say 2a square, then the variable is a and its highest power is a power 2. So in such cases, when there is a single variable in the term or in the expression, then the highest power of a, which is 2, will be the degree of the expression. However, when there are two variables, for example here there are two variables a and b, the highest power of a is a power 2 and the highest power of b is b power 8. So in such cases, when there are two variables, then you add the highest power of both the variables, 2 plus 8. The degree of this polynomial is 10. Answer will be option number B. So when there is a single variable, the degree will be the highest power of the variable. If there are two variables or more than two variables, then you add the highest power of all the variables. That will be the degree of the polynomial. The degree of a constant term. Now what do we understand by the constant term? Constant term whose value remains the same. And constant terms are generally the numbers. For example 2, 3, 5 or 5 by 6. So what is the meaning of degree of a constant term? Now whenever the concept of degree comes, there should be a variable. But if I take a constant term 5, here there is no variable. So to give this a constant term a degree, we multiply it by x to the power of 0. Now x is our variable, and remember that a variable x power 0, its value is 1. So 5 multiplied by x to the power of 0 will give me 5 multiplied by 1. The value of x power 0 is 1, which will be same as 5. Then you will ask, then if the value is coming same as 5, then why we are multiplying this by x power 0? We are multiplying this by x power 0 because to find out the degree, we should have a variable term. And since right now 5 is only a constant number, there is no variable term, I will multiply it with the variable term x power 0. Now why I have taken x power 0? X power 0 value is 1. And when you multiply x power 0 with 5, we know that x power 0 is 1. So 5 multiplied by 1 will give me 5. So multiplying it with x power 0 is basically giving it a variable. Here the variable is x, his power is 0. Degree of a polynomial or degree of a constant term here will be taken as degree of this variable x. The power of x is 0. So degree of constant term 5 will be 0. Answer is option number B. This term is actually mentioned in most of the reference books. However, they do not explain why the degree of a constant term is 0. But I hope now it is clear. Answer is option B. Degree of the polynomial a square plus 1 bracket a plus 2 bracket a cube plus 3. Now here my variable is a,
And if you look that the highest power of a is 3, and if you go by this, that highest power of a is 3, so degree of polynomial is 3, it will give you the wrong answer. On a deeper look, on a closer look, you will see that this is a square plus 1 bracket a plus 2 bracket a cube plus 3. This is actually a multiplication. So what we have to do is we have to first multiply these terms, and then we have to find out that what is the value of a in terms of its power is coming. This is a plus 2, this is a cube plus 3. Let us now first multiply the first two terms, a square into a. This a can be written as a power 1, so a square into a power 1 is a cube. A square into 2 is plus 2a square. 1 into a power 1 is plus 1a. 1 into plus 2 is plus 2. And now we will multiply a cube plus 3 with this term. A cube multiplied by a cube, a cube multiplied by a cube will use the law of exponent. A to the power of m multiplied by a to the power of n equals a power m plus n. This will give me a power 3 plus 3, which is a power 6. So a cube multiplied by a cube will be a power 3 plus 3, 6. Now a cube multiplied the second term 3 will give me 3a cube. Let's multiply 2a square with both terms. 2a square multiplied by a cube will give me 2a to the power of 5. I'll do it here for you. 2a square multiplied by a cube. Now remember, when the bases are same, a and a, powers will be multiplied when the operation is, powers are added when the operation is multiplication. So this will become 2a power of 2 plus 3, which is 2a power of 5. So this term 2a square multiplied by a cube will be 2a power of 5. Now 2a multiplied by 3 will be 2 into 3, 6a square. Next, 1a multiplied by a cube will be 1a to the power of 4. This is power 1, this is power 3. 1 plus 3, it will give me a power 4. Plus 1a multiplied by 3 is 3a. Let's multiply 2 with a cube, it will be 2a cube. Let's multiply 2 by 3, it will be plus 6. Now, let's look at the variable a. Its highest power is a power 6. So the degree will be 6. Subsequently, you could have found the answer without doing this long step. You could have just multiplied the term a in all the three, which could have given you a square multiplied by a multiplied by a cube, which will become a square multiplied by only a is a power 1 multiplied by a cube. So bases are same, it will become a power 2 plus 1, add the powers, 2 plus 1 plus 3, which will give you a power 6. Now this was the easiest way of finding the degree or finding the highest power of the variable. But if the question turns complicated or twisted, you should understand that this method will actually, the longer method will help you to get the right answer. Otherwise, if the question is simple, you can directly multiply the variables and find the direct answer or the direct power of a, which is 6, which will give you the answer of the degree, which is option number B. If the degree of the polynomial bracket p power 6 plus 3 upon 7 equals p power n plus 3p is 9, then what is the value of n? So here the degree of p, the variable p is 9. For solving this question, the longer approach will be that you multiply all the terms and then find the degree of the variable p, and the easy approach will be you only multiply the variable with the variable. The first term variable is p power 6, second term variable is p power 9, and then you equate it with the degree of the polynomial, which is 9. I will show you both the approach. In the first, or the short approach, take the first term p power 6 multiplied with the second term of p, which is p power n, and this will give me the degree of the polynomial, which is the highest power of p, which is 9. So this is my equation. P power 6 multiplied by p power n will give me p power 9. Now when the bases are same, remember, powers are also same. So 6 plus n, the base is same, operation is multiply, so powers are added. So remember, 6 plus n is equal to 9. So the value of n will give me 9 minus 6. So the value of n will be given by 9 minus 6 as 3. A very simple approach. However, a longer approach could have been to multiply all of them and then find the degree of the power or degree of the whole polynomial in terms of degree of highest power of p in the first term and the highest power of p in the second term, and equating with the degree of the polynomial, which is p power 9. P power 6 plus 3 upon 7 multiplied by p power n plus 3p. P power 6 into p power n will be p power 6 plus n. Because bases are same, powers will be added. P power 6 plus 3p will be plus 3p power 7. This is power 6, this is power 1. 6 plus 1, it will be 3p power 7. Multiply 3 upon 7 by p power n, it will be 3 upon 7 p power n. And here, next term, 3 upon 7 multiplied by 3 power p1, this will be plus 3 upon 7 into 3 p1. This is 3 into 3, this will become 9 upon 7 p power 1. Now if you look in this equation, I have the highest power of p as 7 here, and another power of p is 6 plus n here. But according to the question, the highest power or the degree of the polynomial, which is highest power, is 9. So it means we should not take this p power 7, rather we will equate p power 9 with p power 6 plus n. P power 6 plus n equals to 9. Bases are same, powers are same. Equate 6 plus n equals to 9. This will also give you the same equation, n equals to 3. Answer is option number B. The sum of three expression is x square plus y square plus z square. If two of them are 4x square minus 5y square plus 3z square and minus 3x square plus 4y square plus 2z square, then what is the third expression? For finding the answer, what we have to do is, we have to first add these two expressions, and to get the value of the third expression, we have to subtract the sum of these two expressions by the final answer, x square plus y square plus z square. So our equation will be x square plus y square plus z square plus minus 3x square plus 4y square plus 2z square. Let us add these two terms. Let's look at the like terms. This is plus 4x square, this is minus 3x square, plus 4 minus 3 is plus 1, so it will be plus 1x square. This is minus 5y square, this is plus 4y square, minus 5 plus 4. Only work out with the coefficient or the numeral coefficient, because the variable y square will be y square only. Minus 5 plus 4 is minus 1, so it will become minus 1 y square. Now remember, minus 1 y square is actually equal to minus y square, but just for the sake of calculation we are keeping minus 1 here so that it should not create a confusion. This is plus 3z square, this is plus 2z square, plus 3 plus 2 is plus 5z square. So this is plus 5 z square. So this is the addition value of these two terms. And now we have to subtract this term from x square plus y square plus z square. For the sake of convenience, I will make this 1x square as 1, y square as 1y square, and z square as 1z square. Now remember, when we are subtracting, the signs will change. It will become 1x square plus 1y square plus 1z square. Now minus plus, this will be minus 1x square, minus minus, this will be plus 1y square, minus plus, this is minus 5z square. Now let us operate them. This is plus 1x square, this is minus 1x square, cancelled. This is plus 1y square, this is plus 1y square, plus 1 will be plus 2, so this will become plus 2y square, plus 1z square minus 5z square, plus 1 minus 5 is minus 4, so this will be minus 4z square. Here this question is actually incorrect. Why this question is incorrect? Since this option is not in the answer. Because this question is incorrect. To get the answer out of these four options, we have to convert this plus 2z square into minus 2z square, and then you will see that we will get our answer. I will solve it and show you that why this question is wrong and what should be the answer if I change this plus 2z square to minus 2z square. Now I will change this term plus 2z square to minus 2z square. It will become plus 4x square minus 3x square, it is plus 1x square. Minus 5y square plus 4y square is minus 1y square. Plus 3z square minus 2z square is plus 1z square. And now we subtract this term from x square plus y square plus z square. As we discussed earlier, when we subtract, the sign will change. It will become x square. Now I'll give them the coefficient 1, which is hidden. This is 1x square plus 1y square plus 1z square. Minus plus is minus 1x square. Minus minus, this is plus 1y square. And minus plus, this is minus 1z square. This is plus 1x square. This is minus 1x square. Like terms, opposite sign, they will cancel. Plus 1y square plus 1y square plus 1 is plus 2y square. This is plus 1z square. This is minus 1z square. Cancel. My final answer is plus 2y square, which is my option number B. This question was asked in NDA exam, which was actually an incorrect question. So in the real exam also, the questions can be wrong. However, by the corrected value, we have got our answer as option number B. So remember, if in the exam you get an incorrect question where you are not getting the answer, if you are confident of your solution and you are still not getting the answer, do not leave the question, mark any of the options. When you mark any of the options, if the question is incorrect, you will still get the answer. But if you leave the question, you will not get any marks. But if you mark any of the options, even though the answer is not correct, you will still be correct. You will still be identified as the correct answer. Answer here is option number B, after the corrected value of plus 2z square as minus 2z square. If P is 3x minus 4y minus 8z, Q is minus 10y plus 7x plus 11z, and R is 19z minus 6y plus 4x, they are asking the value of P minus Q plus R. P is 3x minus 4y minus 8z minus Q will be minus 10y plus 7x plus 11z plus 19z minus 6y plus 4x. Now remember, in case of subtraction, you have to change the sign here. It will become 3x minus 4y minus 8x minus minus, this is plus 10y minus plus is minus 7x minus plus, this is minus 11z plus 19z minus 6y plus 4x. Now here remember, there is a plus sign, so here no change of sign will occur. It will occur only in case of subtraction. Now let us consider the like terms. This is plus 3x, this is minus 7x, this is plus 4x, plus 3 minus 7 plus 4, plus 3 minus 7 is minus 4, minus 4 plus 4 is 0, so they all are cancelled. No need of writing a 0. Let's take the second term, minus 4y plus 10y minus 6y minus 4 plus 10 minus 6. Minus 4 plus 10 is plus 6. Plus 6 minus 6, again I get 0. So they all are cancelled. Now let's take, this is 8z minus 8z minus 11z plus 19z minus 8 minus 11 plus 19. Minus 8 minus 11 is minus 19. Minus 19 plus 19 will give me 0. So these also are also cancelled. My final answer is 0, which is option number